Our video today is going to take us through percent of change. You're going to be dealing with a couple little formulas, taking a percentage, moving into a decimal, and then making sure that you read the question properly, because there are some things that you don't have to do and then do have to do in regards to what the problem is asking you. So let's get started. For what we have, there's a couple terms that we need to talk about, and that is in percent of change, they're going to give you two numbers, and then you're asked to find the percent of change as it goes through. So when they talk about the original number we're going to label with an O, the new we're going to label with an N. And as you look at these, you're going to be given a little bit of a formula in regards to, is it a percent of increase or is it a percent of decrease as you go through this. So if we look at the percent of increase formula, you're looking at taking the new number, because that's going to be the bigger number of the two. We're going to subtract the original. That's going to give you a difference when you subtract the two. From here, this step is always the same. We're going to divide by the original. That's going to give us a decimal, which we're going to multiply by 100, which is going to turn it into a percent. And because the new is bigger than the old or the original, that is an increase of percentage. Now, for when we look at percent of decrease, it kind of looks the same in what we're doing, but it goes a little bit, changes a little bit at the beginning of this, because you always want to subtract with a positive number at the end. So decrease means that our original is going to be bigger than our new. So our original number is going to be first. We're going to minus our new number, and then we're going to get that difference again, but we're always going to be dividing by the original. Again, that's going to give us a decimal answer, which we can multiply by 2, or we can just move our decimal 2 places to the right. Either or is fine, and that is going to give you your percentage, in this case, of a decrease. So, and they may have you put, an I for increase or D for decrease as you go through it. So those are the two formulas that you're going to work with. Some of the times in here, some of the times you're just going to go straight forward of multiplying and getting your answer for what you're doing. So let's take a look at some examples. So once we have the problems identified, and now the question is, what is the O, what is the new? So when we look at certain questions, they're pretty self-explanatory. In this case, we have the initial value, final value, just another way of using original and new. So if you look at these, again, initial value, final value, again, original, new, as we go through it. Sometimes they won't label them, and you have to kind of look a little bit closer, and generally what you're going to find is the first one is going to be the original number, the second one is going to be the new number as you go through it. So just be careful as you go, and you can see here that you have, again, the first number is the original one that we're working with, and the second one is the new number. So looking at a couple problems, we'll start with first one here. A new washing machine uses 40% less water than the older model. A family uses 1,320 gallons of water per month to run the old one. How much water will they use each month to run the new washing machine? So again, the first step that we're going to take care of is making sure that our decimal of 40% goes into a decimal, and we can leave it as 0.4. Our next step would be to we're going to multiply our percentage times a number that's in the problem, and when we end up doing that, we end up with 528 gallons. Now you'll notice that this is an answer, but it's not your actual correct answer, because they want to know how much water will they save when they run the new washer. So what we're going to end up having to do is take our 1320, and we're going to have to subtract it for 528, and that's going to give us a total of 792 gallons that they're going to save for that. So just be careful as you go through this. Not always the answer is the first one that you get. So for the second problem that we have, we're looking at profit of a store. Our percentages are 72% increase. She made $200 in profit. How much profit did she make the second month? So when we look at that, again, we're going to take our 2,000, and we're going to take that times our decimal of what used to be a percentage, 2,000 times 0.72, and that's ending up to be 1,440. We want to add that to the 2,000 because we want to know what she made the second month. So we're going to add our 2,000 and our 1,440 to that, and we end up with 3,440 for what she made for the second month as well. So sometimes that if they just want to know this part, you got to make sure that you're reading the question carefully as you move through these. Looking at these next problems, they're multi-step in the sense of they're more than one thing that we're looking at, so we've got to be, again, careful in setting up our problem. So if you kind of go through this and be neat about it, things will kind of work to your advantage for that. So if we start off, we're going to put, we have 24 dogs and we have 16 cats. We're going to use the same percentage here, 25 and 25. But if you notice that in this, the number of dogs decreased, so we're going to kind of label this here, and in the same, the cats increased. So the first thing, again, is we're going to take this both times 25 as a 25% as a decimal. That's going to end up giving us for each individual item 6 dogs and 4 cats. Because we decreased the dogs, we're going to subtract that from 24, and I know I'm writing it backwards in the sense, but we know that we can't get negative dogs or negative cats, so keep that in mind as you go through it. We're going to come up with an answer here of 18, and we would actually add the 16 to the 4 because we increased our number of cats, and that would give us a total of 20. So the other thing that we want to do is we want to now find the original, because we want to find the percent of decrease. So we want to combine these two to see what the total is for the original number of what we started with and then the new number of what we ended with after we lost a certain amount of dogs and gained some cats. From there, we're going to take and subtract those two numbers, 40 minus 38. That's going to give us 2 as the difference. We're going to take that 2 and we're going to divide it by the original, and that's going to give us a decimal of 0.05, which we change into a percent of 5% for the percent of decrease that the dogs had, or dogs and cats. So in the second part, we don't necessarily have to find out a percentage, we just want to know how many more bacteria does the second plate have than the first. So the setup is kind of the same. So we end up with plate 1 has 2,200 bacteria. Plate 2 has 3,400. So we're both increasing, or we're taking this times our percentage as a decimal of 90%. That's going to give us a new number of, in this case, 1,980 and 3,060 for plate 2. Now, one of the things that we said was the plate had this many, this many, this many. In the cat one, we don't have to worry about this one in the sense that we don't have to add or subtract anything. So we're going to take care of now, we got to figure out how many total bacteria are on plate 1 and total on plate 2. So we're going to bring back the original number of 2,200, and we're going to bring back the 3,400 for this one, and that's going to give us a total for how many bacteria are on each of the plates. And what we end up with for plate 1 is going to end up to be 4,180, and for plate 2 is 6,460. And again, I just want to know how much more it is on that plate, so I'm going to take plate 2, 6,460, and I'm going to minus it from 4,180 to give us a total of 2,280 to come up to be our answer for this. So looking at a couple other ones that are similar in the scheme of things here, we have a car dealership that has 640 cars. We have 160 pickups. Over a 2-week period, our percentage is going to be 10%. So again, the first step that I'm going to do is multiply this by 0.1. That's going to give us our new inventory in a sense of what we have changed our numbers as. So we have 64 new cars and 16 pickups. If we notice, and again, we decreased the pickups and we increased the cars. So the pickups went down, the cars went up. So again, with the cars, we're going to add our 64 to our 640. And from what we can, when we add those two together, we get a total of 704. We're going to actually take the 16, and again, we're going to minus that from 160, which leaves us left with 144. So again, we're going to add these two totals up to get a original and a new number. So that's going to end up being here 800, and that over here is going to be 848. We're going to take these two numbers and we're going to subtract them. So 848 minus 800. Again, we're trying to get a positive number. And then we're going to take that 48 and we're going to divide it by the original number of 800, which is going to give us a decimal of 0.06, which we can turn into a percent of 6%. So again, if they're looking for a percent of increase, you have to finish the problem in that order. Again, with the similar one to what we did with the last one on the last slide, we have now a biologist that's studying ants and bees. So again, setting up a table in a sense is kind of what we're doing. It may not look like a table, but it kind of is as we go through this. We notice that we increase our bee population, we decrease our ant population. So we have a total of 32,000 bees, and we have 34,000 ants. They both did something by 10%, so again, we always going to be multiplying that by a decimal. That's going to give us a new number to work with. This is going to be 3,200. This ends up to be 3,400. So again, the bees increase, so we're going to add that to it. So we're going to add 32,000, and we subtract 34,000 because we lost ants in that case. That's going to give us a new number here of 35,200 bees and 30,600 ants. So all we now have to do here is, because we just want to know how many more bees than there are ants, we're going to take those two and we're going to subtract them, and we end up with a total of 4,600 to be our complete answer for this one. So the keys to these problems are, 1, make sure that you're looking and finding your keywords to get that understood of increased, decreased, withdraw, deposited, so forth. Make your decimal or make your percentage into a decimal as you go through it. Make it a problem a little bit one less step. Be neat with your steps. Make sure you know where you're going, what they're asking you, and understand whether you have to find a percent of increase or decrease, or if you just have to find the subtraction of two numbers. And when you do set up that subtraction problem, always set it up as a positive result. So that way you're never working with a negative number in this section. So if you do come up with a negative number, something went wrong and you don't want to be doing that. So use those, show your steps, and you should be fine with this section.